No question. Good morning, everyone. Now, binary tree. So let's revise binary tree so that we can solve a question on a binary tree. So like I said earlier, binary means twos, right? Maximum of two. Tree in form of a tree. You know that a tree has roots, which is the most important part of a tree. And it can have one stem. That is one. If it has one stem, that means it has only one child. So the stem can have two children. Each stem can have two children or one child or no child. This stem again can have two children. Let's assume this has no child. This can have one child, two children. So you can see that all these have maximum of two children and in form of a tree, where this is the root. So this is what? This is a tree. But because of the maximum number of children each stem has is what? Is two. Then we say this is what? Binary. That comes from the concept of the binary tree. So the root is the parent. Let me say the first parent. Each stem is also a parent. So this is the old parent, that is the oldest parent or the first parent. So we call it the what? The root. Is that understood? This is another parent. Why is it a parent? It has two children. Okay, so this is a parent. Now, this is another parent because it has one child. This is another parent, it has two children, but this is not a parent. It does not have any child, right? So this is another parent with two children. This is another parent with two children. These two guys do not have children, so you can't call them parents. So that is the concept or how you should view binary tree. So let's now come back to computer science. Binary tree is an abstract data type. Okay, so like I said, abstract means something you cannot see. Abstract is abstract, you cannot see. It's an operation, is the way data are arranged. That manner or process in which data is arranged, then we say is a data type. That process is the binary tree, just like queue and stack. So let's have an illustration so that you can understand what it is. So binary tree consists of nodes. A node is a data. Like I always tell you, a node is a data. So let's take, for example, you want to add a value to this binary tree. We can represent the binary tree in two forms, either as a tree, the way you have it this way, as a tree, or represented in an array. To write your code with Visual Studio Code, you are going to run your code on console, on terminal. That means you cannot print this tree except if you are using a graphic user interface. So to print this in your own console, that means you must implement this in an array. It's easy to print an array using the console. So we are going to implement this in an array, which will be more easy. Okay, so let's add value. So I will represent the two binary tree in a graphical form and in an array form. So like I said, there's always a node in binary tree. So to represent in an array form, we need a 2D array or 3-1D array. If you're using a 2D array or 3-1D array, the reason is because for every node, I will show you the reason now. Let's take, for example, we want to add a value to this string. The first thing, let's assume we want to add a 5, for example. So this node has value 5. Because it is the first data, there is no data to the left or to the right. So at the left, there's no value. At the right, there's no value. That is the first value. If you want to add another value, then you have to compare with the root node. So this value is called the root node. That term is very, very important because it makes you identify which one is the first value. So the first value is the root node, just like the root that holds everything. So if you want to add another value, let's take, for example, a 6. You have to compare with the root node. That is the most important thing. Compare it with the root node. If it is greater or equal to, that means you have to move to the right. If it is less than, you move towards the left. That is the principle. Okay? So to add a 6, you have to compare the 6 with the root node, which is a what? Which is a 5. It is greater, isn't it? Since it is greater, that means you move towards the right. So at the right, there is no value at the right, right? So you have to put it there and write 6. If you want to add a 7, for example, you still must compare with the root node. That's why you must identify the root node. The first node is the root node. It's very important. You keep comparing any value with the root node. So if you want to bring in a 7, the first thing to do is to compare it with the root node, which is the what? Which is the 5. Of course, it is what? It is greater, isn't it? Since it is greater, that means it tends towards the right. So at the right hand side, is there a value? Yes, isn't it? Since there is a value at the right, so you will compare it with that value at the right to see if it is greater or less. So if it is less, it tends towards the left of that value. If it is greater, it tends towards the right of that value. Do you guys understand that? So since it's greater, that means the 7 tends towards the what? Towards the right, and so on. So this is how it works. So how do you represent it in what? In the array. So let me clean this and start again so we can see the representation in the array. So if you take a look at this, we either moving to the left or to the right, isn't it? So that means we need the left pointer, we need the data, and right pointer. Okay. Now, at first, if there was no data in the array, that means that there is no node or there are empty nodes. Yes, we can say there are empty nodes or no node. It depends on the term you want to use. So if there are empty nodes, that implies that the nodes must have been pointing to each other if they are empty nodes, right? But if there is no node, that means there is no pointer. Nothing is pointing. So the pointer means you are pointing to the index where the node is, it can be found. For example, if you want to add the first data, if it is 5, for example, that means 5 can be added to the array. So that is at what index? What? Index 0. So that means the root node can be found where? At index 0. Is that understood? That means the root node can be found at index 0. So to the left, to the right, there is no value because that is the first value. So this is the root node. That means the value of the root node is equal to what? Is equal to 0. Because the root node is the pointer that points to the index of the first element, or that points to the index of the first node in the what? In the binary tree. Is this understood, everyone? Good. So if you want to add another value, let's take, for example, 9. You have to compare 9 to 5, isn't it? So since 9 is greater than 5, that means the value tends towards the right. So this is 9. That means you have to add 9 to the array. Is that understood? That means it must be at what? Index 1 to add 9 with the array. So 9 is added at index 1. That means at the right hand side of 5, there is index 1. That means 5 points to index 1. That is what it means. So that means the right pointer of 5 must be 1. So the right pointer of 5 must be 1. Do you understand? The left pointer of 1 is nothing because there is no value to the left of 5, isn't it? The left pointer of 5 is still nothing because there is no value to the left of 5. So because pointers point to index, so I can represent a null index as what? As -1. Why? Because -1 means it is not a valid index of the array, isn't it? So that means I can initialize all this index to what? To -1. -1 because 5 is pointing to nothing at the left. 9, which is the one at the right, is also pointing to nothing at both the left and right, isn't it? So which makes sense. So I can write that the left pointer of 9 is -1, the right pointer of 9 is -1. The right pointer of 5 is 1, the left pointer of 5 is -1. So that gives me the interpretation of that array. So telling you that what you are seeing in the binary tree is the same thing as what you are seeing in the array. I hope you guys understand that. So we're using array because we are not using the GUI, so it will be difficult to print that tree in that structure. We can print the array from our IDE. Understood, everyone? Okay, good. So if you now want to add, let's say 5, for example. So that means, like I said, we have nodes. Each data is a node. So that means we can have the maximum number of nodes in the binary tree. So the question or the instruction will tell you the maximum number of nodes you can have in a binary tree. So if the question says we have, let's take for example, 7 nodes. The maximum number of nodes is 7. That means I have 0, 1. The index will be 0, 1, 2, 3, 4, 5, 6. That means the maximum number of nodes is what? Is 7. So that means for each node, the left pointers are what? -1, can be initialized to -1. The right pointers can be initialized to what? -1. Why? Because each node data has an empty value. Okay? They are empty values. For it to be empty values, that means there is no value at the left or right, so we can just initialize them as -1. So that means from the start, before any value was added, there was no value in the what? In this. So this cannot be 1 because there was no value. Everything can be initialized to what? To -1. So that means we're starting. So the question can also ask you to initialize the data column. The data column is not initialized as you see in this question. You may be asked to initialize it to 0. You can even be asked to initialize it to -1 or asked to initialize it to any value. So the question will tell you what you need to do at this point. And the question may even ask you not to initialize it. I don't know. It depends on whatever question you're working on, whether it's a 2D array or 3 1D array. If it's a 3 1D array, they may ask you not to initialize the data array. If it's a 2D array, of course, they will ask you to initialize. So it depends on how the question comes. Just put your attention or put your mind in whatever question you want to solve. I hope you guys understand that. So I'm using a dot to what? To represent an empty value. Do you guys understand that? So let's now start again. So to add a value, so we want to develop the algorithm to add a value to the binary tree. That is our aim. Develop an algorithm to add a value to the binary tree. So to add a value to this tree, we know that the maximum number of nodes this tree can have is what? Is 7. So before we can add any value, we need to check if the tree is full. Because it has a what? It has a limit. If the tree is full, that means we cannot add. If it is not full, that means we can add. So if you take a look at this, we can check if it is full or not by checking if what? If whatever, because you cannot see the binary tree when you are writing your code. So you must use some variables to what? To track. But we're coming back to that later because we're not writing the code. We want to see the illustration, how it looks like. Now, let's assume we want to add a value. We're adding the first value. Of course, it is not full, right? We want to add a value which is what? Which is 20. That means 20 will be what? Will be added. So at the left-hand side of 20, there is no value. At the right-hand side, there is no value. Although 20 is stored at what? As index 0. That means the root node is equal to what? Is equal to 0. At the left-hand side, it is pointing to -1. At the right-hand side, it's pointing to -1. That means it's pointing to what? To null index. Because there are no values at the left or right. Does that make sense? Which is exactly what you have in your what? Array representation. And that's why you have to initialize those left pointer and what? And right pointer. It's very important. Now, let's now take, for example, you want to add another value. Let's say 17, for example. Like I said, you must compare the new value with the root value. To add 17, you have to compare 17 to 20, right? So which is what? Which is less. So I said if it is lesser, you move to the left. If it is greater or equal, you move to the right. So since 17 is lesser, that means you have to move towards the left. So is there a value at the left? No. How do you know? Because the left pointer of the root node is what? Is -1. Do you guys understand that? So if the left pointer of a node is -1, or that means that there is no value at the left. If the right pointer of the node is -1, it means there is no value at the right. Is that understood? So we want to add 17. So 17 is less than 20, and the left pointer is -1. That means we can add 17, isn't it? So 17 has been added. 17 is added where? To index 1, isn't it? So that means you have to update the left pointer of 20 to what? To index 1, because 17 has been added to index 1, isn't it? So that means you have to go back here, update the left pointer of what? Of 20 to what? To 1. You have to update. It was initialized to -1. You have to keep updating. So that develops the algorithm. So let's take, for example, you now want to add, let's say, 19. Of course, you have to compare with the root node first. If you compare 19 with the root node, 19 is also what? Is less, right? That means you have to tend towards the left. So what is the left pointer of 20? It is not -1. Since it is not -1, that means there is a value at index 1, isn't it? So you have to compare with that value. So comparing 19 with 17, what does that imply? 19 is more than 17. That means it can be found at where? It should be stored at the what? At the right of 17. So that means 19 is added to what? Index 2. That means at the right hand side of 17 is what? So the right pointer of 17 is index 2. So you have to go to the right pointer of 17. So this is the right pointer of 17. You update it to what? To 2. I hope you guys understand that. So let's now add a value, let's say 23, for example. Of course, like I said, you have to recompare with the what? With the root node again, isn't it? So compare with the root node again. 23 is more than 20. That means it should tend towards the right. So at the right hand side, what is the right pointer of 20? -1. That means there is no value, isn't it? So that means you have to add a node, which is 23. So 23 is added to what? Index 3. So that means you have to update the right pointer of 20 from -1 to what? To 3. Okay, so you have to update the right pointer of 20 to 3. So this is the graphical illustration at the left. This is the array illustration at the right. So they all mean both of them mean the same thing. This is just the graphical representation. This is the array representation. So you continue to add until the binary tree is full. I hope this is well understood. So that means if I want to add 15, 15 is less than 20, 15 is less than 17. So I have 15 here. So 15 is added to index 4, isn't it? Index 4. That means that is left hand side of 17. I have to go to the left hand side of 17 and update to what? To 4. If I want to add 18, 18 is also at the left, at the right, isn't it? 18 is added to what? Index 5. That is the left hand side of 19, not the right hand side. So that is left hand side 18, which is added to index 5. That means the left pointer of 19 will be updated from -1 to what? To 5. Then lastly, if I want to add, let's say 22, 22 is greater than 20, less than 23. So 22 is added to what? Index 6. That means I have to what? Update the left pointer of 23 from what? -1 to what? To 6. So this turns to 6. And can I add another value? No, because the maximum number of nodes for this binary tree has been reached. That is the concept of binary tree. I hope this is well understood. So let's solve an equation. There are many ways questions can be set on binary tree. So let's solve this question on binary tree. So see me in the next.